This is chapter 1.7, exercise 1 through 25. This section in our book 1.7 has to do with inverses of functions. In this exercise set here, 1 through 12, graph each function, apply the horizontal line test to determine whether its inverse function exists, write yes or no. So some of these we're going to go ahead and use a calculator for, and others we're going to be able just to sketch a graph without using a calculator, so I'm going to kind of mix and match here. This first one here, I'm going to just enter the calculator. We have x squared plus 6x plus 9. And if we run a horizontal line through this function, we can see that that horizontal line will touch twice. Therefore, when we make an inverse of this relation, an inverse is not going to be a function. And so I'm just going to quickly sketch what that looks like. Okay, we are over here to the left. Three units. So our function is going to look like this. And its inverse is going to be this one here I'm sketching in red. Okay, so the horizontal line test on this original function determines that when we take the inverse, which is here in red, is not going to be a function. So we will say to this one, no, and we will say fails the horizontal line test. Next problem, 3. Okay, this one here is going to be really similar to problem 1. I'm going to go ahead and graph this without a calculator. We can rewrite this function as f of x equals 20x minus 5 squared. And so what we have is this function here. We have a double root at x equals 5. And so we're going to come like this. That's roughly, it's wider than the actual parabola. But if we draw a horizontal line, which I just did, that horizontal line is going to touch this more than once. And so in a similar manner to problem number 1, we will say also no, fails horizontal line test. Problem 5, we have f of x equals the square root of 2x. The parent function for this is going to be the function f of x equals square root of x. And so we should recall what that looks like. That's going to be f of x equals square root of x is going to look something like this. So what's happening here with this particular one, we have, just rewriting this, we have f of x equals, we can pull this 2 out of the radical, so we're going to get square root of 2 times square root of x. So what it's going to do is stretch this original parent function. I'll put f of x equals square root of x by a factor of 2. So it's a factor of square root of 2 rather. So it's going to be something like this. So f of x square root of 2x. And then if we do a horizontal line test on this red curve, we see that horizontal line touches only once. So to this we will say, yes, the inverse function does exist. And we're going to get a quadratic function. We're going to have to restrict the domain of that function to get it right. Okay. Next, problem 7, which is going to be very similar to problem 5. I'm just going to sketch this one by hand again. We have f of x equals square root of quantity x plus 4. What that's going to do is move our basic square root function. I'm just going to graph the square root function like this. And what it's going to do is going to take that basic square root function and shift it 4 units to the left like this. There it is. And we should be able to see that, just like problem 5, horizontal line, horizontal line, it's a little better looking horizontal line. We'll touch this curve only once. So this we say, yes, passes the horizontal line test. Next, problem 9. We have f of x equals 5 over x minus 6. This is a variation of the parent reciprocal function, which is f of x equals 1 over x. So let's go ahead and just graph this particular function with the calculator. Okay, we have 5 over x minus 6. We enter that, and we see we could run a horizontal line, and the horizontal line will touch only once. We have a vertical asymptote here, it looks like, at x equals 6, which makes sense from this function, non-removable discontinuity at x equals 6, infinite discontinuity. And so for this one, having graphed it and looked at it, we will say, yes, passes horizontal line test. And next, algebra problem 11, we have f of x equals x cubed minus 9. What we have here is, you might recall, I hope, the parent cubic function, which is f of x equals x cubed. And what we're going to do with this x cubed minus 9 is just take the parent function and shift that, graph that function down 9 units. So I'm just going to freehand sketch the parent, graph the parent function, something like this. And then we're going to shift this function down 3, 4, 5, 6, 7, 8, 9, down 9 units. So we take this curve, shift it down 9 units. And if we draw a horizontal line, that horizontal line is going to touch the curve of this function only once. So to this one we say also yes, passes the horizontal line test. Next, let's go to the next algebra problem, which is 13. Now we're into a new set. Exercise 13 to 25. Determine whether each function has an inverse function. If it does, find the inverse function. State any restrictions on its domain. Now, we have a quartic function here. It looks like it's a negative quartic function. So conceptually, the thing is going to start low and end low. So it's going to come from low like this, and we don't know what exactly, and then end up low like this. So probably it's not going to pass the horizontal line test, but let's go ahead and take a look at this in graph. Control I, at graph, negative 3x to the fourth power. And plus 8x squared minus x. So we graph this function, and yes, we see that this does not pass the horizontal line test. So we will say, does it have an inverse function? We say no. And just like some early problems, fails the horizontal line test. Next, problem 15. We have h of x equals x to the seventh power plus 2x cubed minus 10x squared. As opposed to number 13, where we had a negative even degree. This one here, we know we have a positive leading term, so we know we're going to start low and we're going to end high. Now the thing we don't know is in between the low and the high what's going to happen. Could be like this, could be like this one in black, where we don't actually double back, so we don't know for sure if this thing is going to pass the horizontal line test without graphing. So if we press Control I, or without greater understanding, intuition that I now have, we have x to the seventh power plus 2x cubed minus 10x squared. I think this minus 10x squared is what does the trick. And we can see that we, again, don't pass the horizontal line test. So we will answer this like we did number 13. No. Fails the horizontal line test. Next, on number problem 17, we have f of x equals square root of quantity 6 minus x squared. Now I happen to know what this is going to look like, but I'm going to make an assumption that probably my average pre-calculus student may not recognize what this is, especially we haven't gone over the unit circle yet in our school year. I'll do that next semester. So let's go ahead and graph this function. Control I. At graph, we have square root of quantity 6 minus x squared, and we get a semicircle. It's a semicircle with a radius of square root of 6. So, get back here. So square root of 6, like this. So it's going to come like this. Not the greatest looking circle, semicircle. But we should be able to see that this thing is not going to pass the horizontal line test. So here we go. We say, like many of these others, no, fails horizontal line test. Next, under problem 19, we have f of x equals 4 minus x over x. And we'll just quickly graph this one. Okay, we have 4 minus x, x. So this one here looks like it is going to pass the horizontal line test. There's a horizontal asymptote here at x equals -1, or y equals -1 rather. So so the passage says, if it does, find the inverse function and state any restrictions on its domain. What we're going to do is do our 4-step rewrite process. We're going to change this f of x to y. So we're going to call this y equals 4 minus x over x. Next step, we're going to switch positions of the x and the y. So I'm going to work down below here. I'm going to put x equals 4 minus y over y. And now, to solve for y, we're going to go about the process of clearing out the denominator. So if we multiply both sides of this equation by y, so y on the right side, y on the left side, we have y over y cancel on the right side, and we bring down what's left. We have xy equals 4 minus y. Now, what we're going to do is bring this, all the y's over the left side. So we're going to add y to both sides of this equation, and negative y plus y cancel on the right side. So we have xy plus y is equal to 4. And now between the terms on the left, xy and y is a common factor. So we have y times what equals xy. That's y times x. Y times what equals y. That's 1. So we have y times quantity x plus 1 equals 4. Now if we divide both sides of this equation by x plus 1, we have a cancellation here. So just kind of bringing up to the upper right here, just rewriting, we have y equals 4 over x plus 1. And for this, I don't see any restrictions involved. So we'll say, let me rewrite this in inverse notation. We have f -1 of x equals 4 over quantity x plus 1. So let's go ahead and graph this, see what it looks like. And tab. Over x plus 1. Sometimes with these reciprocal functions, it's really hard to see, but if we run a line y equals x, we can see this burgundy curve and the orange curve will reflect about that line, y equals x. Okay, so let's go ahead and box this in. Another thing it says is state any restrictions to its domain. We will say no domain restrictions. Okay, we're going to have restrictions on the little one here, so I'm pretty sure. Okay, next on our problem, which is 21, we have f of x equals 6 over quantity, or square root of quantity x minus 8 minus x. So going to our calculator, we have 6 over square root of quantity x minus 8 minus x. So we have this curve here, this blue curve. It looks like this thing passes the horizontal line test. So we will say, for this one, we will say yes, passes horizontal line test. And on problem 19, I neglected to mention that. Also, that was kind of the obvious. So this one is also yes, passes HLT, horizontal line test. And once we knew the thing passed the horizontal line test, we were able to go ahead and start solving, finding its inverse function. Okay, so let's go ahead and work this out. First step, I'm going to just work down. We're going to have y, change this to y equals 6 over square root of quantity 8 minus x. Next, we're going to switch positions of the x's and the y's. So I'm going to rewrite this as x equals 6 over square root of quantity 8 minus y. Next, we're going to clear out the denominator by multiplying this whole equation, both sides of this equation, by square root of quantity 8 minus y. And when we do that, we distribute essentially square root of quantity x minus y to x. So now on the left side, we have x times quantity square root of 8 minus y. And on the right side, we have square root of quantity 8 minus y over square root of 8 minus y cancel each other, so we just have 6. And next, we're trying to get this y isolated, and to do that, we're going to square both sides of this equation. So there's a square on the left side, square on the right side. And now what we have, squaring everything, we have x squared times this square root and square cancel each other. So we have 8 minus y. On the right side we have 36. And now if we divide both sides of this equation by x squared, we have cancellation on the left side. So I'm going to bring this here to the upper right. What we have is 8 minus y is equal to 36 over x squared. And then if we subtract 8 from both sides of this equation, we have 8 minus 8 cancel on the left side. We have negative y equals 36 over x squared minus 8. And if we multiply this whole equation by negative 1, we get y equals, instead of 36 over x squared, we have minus 8. We have 8 minus 36 over x squared. And then as a final motion here, what we do is we'll write this in inverse notation. Inverse function of x equals 8 minus 36 over x squared. Now the only thing that remains here for us is this domain restriction, and to do that I'm just going to graph. Let me just graph on the same plane here. We have 8 minus 36 over x squared, and we graph that, and we have these red curves. You might notice that on the right side of the y-axis, this red curve is indeed the reflection about the line y equals x, but this left side of the curve, this red one, is not. So a restriction is that x is going to have to be greater than 0. Of course, we have a vertical asymptote here at x equals 0. So our restriction is going to be x greater than 0. So that is our inverse function with our restriction here. Next on our problem 23, we have f of x equals 6x plus 3 over x minus 8. So to graph this, we have 8x plus 3 over x minus 8. 6x plus 3 over x minus 8. And we see this curve here. I think it's going to be, I want to go ahead and make this a little bigger so we can see a better view of this. So if we change the window settings, I want to change my x max to 20 and my y max here to 20. I think we'll see two parts of the curve. So we see it. We have a vertical asymptote and horizontal asymptote. It has every appearance that this thing passes the horizontal line test. So we will say yes, passes the horizontal line test. Okay, next, to find what that inverse function is, we're going to change this function to y equals 6x plus 3 over x minus 8. And now changing positions of the x's and the y's, we have x equals, we have 6x plus 3. Oh, excuse me, I got that wrong. X equals 6y plus 3 over y minus 8. And we're going to clear out the denominators we've done in the last couple of problems by multiplying both sides by quantity y minus 8. And having done that, on the left side we have x times quantity y minus 8. And on the right side, we did clear out this denominator of y minus 8 over y minus 8. So we have left on the right side 6y plus 3. And now we're going to distribute x to quantity y minus 8 on the left side. So we're going to have xy minus 8x is equal to 6y plus 3. And what we're going to do is get everything with a y in it on the left side, everything without a y on the right side. And to do that, we're going to add 8x to both sides of this equation. So plus 8x over on the right. And then we're going to take this 6y on the right side and subtract it from the right side. And also subtract 6y on the left side. So on the left side we have negative 8x plus 8x cancel, and on the right side we have 6y minus 6y cancel. And what we have left on the left side is xy minus 6y is equal to 8x plus 3. And now I'm going to bring this up to the upper right. We're going to factor out, we have xy minus 6y on the left side, so our common factor between those two is y. So we have y times quantity, x minus 6, is equal to 8x plus 3. And now we divide both sides of this equation by x minus 6. And we have x minus 6 over x minus 6 cancel on the left side. So we're left with y equals 8x plus 3 over x minus 6. And writing an inverse function notation, we have inverse function equals 8x plus 3 over x minus 6. And we know that x cannot equal 6. Let's go ahead and graph this here. See what it looks like. I'm going to leave this in the same window. We have 8x plus 3 over x minus 6. And so about the line y equals x, we have that lavender curve, which is an inverse of that black curve. But again, we have a vertical asymptote at x equals 6. So our restriction is we're going to say that x cannot equal 6. That's our domain restriction. So this is our answer. Now the last exercise in this set is 25. We have g of x equals the absolute value of quantity x plus 3 plus the absolute value of quantity x minus 4. So if we go to control I, and graph, we get the absolute value right next to this 9. So we have x plus 3. Come out here and put plus absolute value of x minus 4. And graphing this, we do not see anything. If we change the window, I think all we have to do is change the y setting here. Window settings. We'll change y max to 15 or 20. Let's change it to 20. Tab down. We see this green decreasing all the way to x equals -3, and constant all the way to x equals 4, then increasing after x equals 4. So this thing fails the horizontal line test. So our answer to this one is no, fails the horizontal line test. So this has been a little bit tedious in that we worked out a couple of reciprocal functions here, which these problems here, 23 and 21, they always involve more algebra. 19 as well. Anyway, good luck on your even number problems, and thanks for viewing.